Good morning and welcome. My name is Bayen. I'm the director of CITRIS. So on behalf of CITRIS, the Center for Information Technology and Research in the Interest of Society and the Banatao Institute, I would like to welcome all of you this morning. And for our online viewers who are watching us, welcome as well. So we're really excited this morning to have 2 hours and a half to share a lot of the developments we've been working on about the Berkeley Space Center. That's me online. So I think what we're going to do this morning is we're going to have a series of presentations, talks, panels, and we are going to have a few sessions where we also enable both people in the audience here physically as well as people online to ask questions. So if you're watching us on YouTube, you can enter questions in the YouTube box, and my counterpart at NASA, Sid Sun, who is here, will be able to read your questions. And so without further ado, so we just send this flight on time. I'm going to ask the first speaker to come. Darek DeFreece is the business lead for the Berkeley Space Center. We used to call him on the campus the founder because he's our longest standing person who's been working on the Berkeley Space Center here, probably in the entire room. And he will first give us a form of an overview of the project, and then we'll dive into the academics and then go into the presentations of NASA. So Darek, if you want to join us.
Good morning, everybody. It's really nice to see you all here on a Monday morning. It's my job to give you the business overview of the project and to describe what we're attempting to build down at NASA Ames. So as I'm going to orientate you on several slides that many of you may have seen before, but I think it bears repeating and gives us something to level set upon. But for those of you who don't know, at the top of the screen on this overview of the Bay Area is, of course, our lovely campus here at UC Berkeley. And down at the bottom is NASA Ames. It's 47 miles, and I've said this many times, but it can take 47 minutes to get there or 4 hours. So it's a challenge just by distance alone, but we've got some ideas in mind as how to solve those things. We're going to start orientating you from an overview image as to why would UC Berkeley be interested in putting a foothold in Silicon Valley. And it's because of this, not just NASA Ames, but what surrounds it. Every single large tech, deep tech company has a presence within a stone's throw of NASA Ames. If you were to plant a flag on Silicon Valley, many of you would place it in different places. You might place it on the Apple Ring, you might put it on the Googleplex, you might put it on Meta, you might put it on that garage where AP started. But if you look at it geographically, the proverbial hole in the donut of Silicon Valley is NASA Ames. You're completely surrounded by intellectual talent and on these very, very large businesses in addition to NASA Ames. So, of course, blue and gold, we're going to start identifying the place where we intend to build the Berkeley Space Center. This triangle represents 36 acres and about 1.4 million square feet of buildable space. For those of you who need to know what that looks like, take a look at the Salesforce Tower. So that's about 1 million square feet. So imagine we were to build 12 buildings, the size of Sutarja, which you're sitting in now, and place it amongst 36 acres, build some conference facilities, put some housing in place, and then you have a robust community that the Berkeley Space Center could be. But take a look here also. You'll see NASA Ames and all of its richness and its assets, which includes the largest wind tunnel in the world, includes labs associated on extreme temperatures, environments, advanced materials, astrobiology. NASA Ames, and you'll get an overview from Center Director Eugene Tu, has just this richness of research that is happening within its directorate. All right. So yes, again, we're looking at putting a large R&D facility down at NASA Ames, which will be mostly occupied by private industry. A very strong amount of space will be those companies that could collaborate and cohabitate with the university and use the intellectual capital that's driven out of NASA Ames, the intellectual capital that's driven from the UC Berkeley campus, mix it all together in a proverbial soup. But let me not have to describe it. let me show you. And many of you seen this video, but I think this commercial is pretty awesome. So I use it every single time I speak. So as you can see, this is the NASA Ames Research Park, and there's the historic Shenandoah Plaza, which looks out over Hangar 1, which will be completing its reskinning at the end of this year. You can see the 36 acres that are being built, many different types of building structures orientated over a central green. We had master planners HOK and James Corner Field Operations do this incredible master plan with us under the direction of our joint development partners, SKS Partners. So Tim Smith from SAS has promised me that that golden bear statue is going to be 12 feet tall. This is our center green, with the idea that every building will have a front door into this center so that we can encourage people to communicate, collaborate, innovate together. All right, and that's going to just lead into our awesome logo. That's going to be a patch on some NASA clothes someday, we hope. All right, let me just get back to this. I have just a couple more slides to show you. And this is really what we're trying to create. This is an innovation center concept. For those of you on the Berkeley campus, you're familiar with the Baker Bioingenuity Hub, right? It has wet labs inside, and those are startups. Those are companies that are launching from that facility. So it really represents a good mix of faculty-led startups, especially others in our community, really being drawn in. So we think that if you put all of these companies together, from emerging startups all the way to legacy primes, and you mix them with the intellectual capital that UC represents, all of its campuses, not just UC Berkeley, and NASA, not just NASA Ames, but the others, you get some really incredible positive outcomes. So what we can do independently as government, academia, and private industry, we can do amazing and great things if we work on new technologies and building new things together. So that's the whole concept of the Berkeley Space Center. Bring private industry in, put a ton of academic resources behind it, and use the intellectual capital from both NASA and UC to build these really incredible positive outcomes. Additional benefits, of course, we have to say that this Berkeley Space Center is not being built with public funds. This is a private-based model with real estate returns, which we intend to use and recycle back into the site to support the academic research mission of UC Berkeley. We also believe that there will be more sponsored research dollars coming into this program because we will identify new problems that we have to tackle. We want to re-educate and educate our workforce. So California can be the leader, especially in all of these disciplines, whether it's advanced aviation, aerospace, quantum, robotics, AI. This is not just about space and what exists beyond our atmosphere. This is about solving really tough problems. And of course, we would be remiss if we wouldn't talk about the philanthropy that could be driven towards this site. Many people want to invest their time and their talent, but also their treasure into these ideas. They will support these ideas and carry them forward. Finally, building the center of itself will increase employment opportunities by really good union-paying jobs. We will protect Northern California's space economy and prevent it from leaving to Colorado and Texas and Arizona, and shoring up the Southern California, El Segundo area and everything that's happening at JPL, drawing deeper connections on the West Coast. And of course, housing is part of our component right now. We think that we can build some housing to support students and student internships on the site without having to bear the cost of Silicon Valley. And this will be a sustainable development. Our SKS partners, our joint venture development partners, is really committing to finding new buildable ways to make those buildings as sustainable and carbon neutral to carbon capture type buildings So this whole research park will in of itself be a research opportunity for that. And finally, this will protect the bay. There is an underground spillway that is happening there where toxic and contaminated water is migrating up into the bay through this site. We will be another barrier cleaning up that groundwater so that it doesn't reach our precious environment. So with that, that's the business side of the presentation, and I get to turn it over to my colleague, Alex. Thank you.
Thank you so much, Darek. And really an opportunity for me to acknowledge Darek has been working on this project since 2018. So really all the institutional agreements and everything that enabled this project to exist really on our campus, we really owe it to Darek. So thank you, Darek. So I'm going to now put on my second hat as the Associate Provost for the Berkeley Space Center. And this is also an opportunity to acknowledge many of the people who have driven from NASA Ames or the peninsula to be here today. Because I think at the core of what we want to do for the project is a lot of the research work, the technology development work, and that's really what we're going to build even before we have a physical campus there. And so people ask, well, what is it exactly you're building? And so I'd like you to think about this in a spatial-temporal frame where initially maybe what we built will start to look a little bit like what would be an industry park. Like think of the Discovery Park at Purdue or Agitech. UC Davis is building something very similar around the theme of agriculture. It's really one of the new models of many of the academic institutions surrounding us, which is a way to mix industry partnership with academic work. If you think a little bit further along the line of time, maybe we will start looking a little bit more like JPL or LBNL here. In fact, the provost, Paul Alivisatos, who launched this program, had a saying, which is the last time we did something as big as we're doing today is when we launched LBNL. And LBNL has this extremely nice mix of faculty and research staff embedded together in the same space to work, which is probably what aspirationally the Berkeley Space Center might look like in a few years. Of course, down the road, if we dream even further, and this is maybe multiple decades now, not even in our physical or my physical lifetime here on this campus, it could be that one day what we're doing evolves into a residential campus or a place which has academic units. We're not doing this today. I mean, obviously, this is multiple decades, but in this global university model, I think there is room for it. And if you look at the NASA Research Park, there are other academic institutions there. So today, when we have the conversations, I think the right way to think about this is that we're evolving on a continuum, and the conversations we have really help create the beginning of that continuum, which will grow over time. We are and will be guided, at least for the years to come, by a vision. That vision was written together by Gordon Rouser and a committee, several members here in this audience. I saw Rebecca is here, and there were a few others. And so I think it's important to recognize that we're doing long-term planning, and long-term means 99 years. This is a 99 years project. And so there is a short-term phase planning. That short-term means 5 years. There is a longer-term phase planning. So if you go to the Berkeley Space Center website, you will find that report. That report is fairly long. It's 100 pages. The point is not to set things in stone. It's a vision at the time of now, but it really guides the way we're going to evolve. And hopefully, as it gets revised, all the inputs of today's conversation become part of the next version of the report. Berkeley has a lot of aspirations at the Berkeley Space Center. Primarily to work with NASA, because that's why we decided to develop it here, but research being the anchor, at least of what we're going to do in the near term. Beyond that, education, entrepreneurship, and academic units might also become part of it. So today, I think we're mostly speaking about research and NASA, and that's why, again, we're very grateful for the presence of NASA on that site. So if you think institutionally who we are, NASA being a federal agency, the UC being the flagship public university in the nation, we're essentially trying to create a space where both can interact. And you're at Citrus today. Citrus, being a multi-campus organization, happens to be one of the prime sub-organization of the UC involved in this. And likely we might be amongst the first to establish a presence there just because we have been working with the team for a long time. So just as a quick digression, if you don't know Citrus, we span 4 campuses, Davis, Merced, and Santa Cruz, all of which have very strong interest to work together with NASA. Let's keep a few slides in the interest of time. And so now you wonder, okay, so the third ball or the first circle in that diagram is the private sector. And that's also part of our talks and conversations today. The private sector really means 2 things here. There is, on one hand, SKS, and Tim Smith is here sitting in the back, and we'll have opportunities to engage as well. And that's really the members of the team that help us build that vision. we're building that vision is not just the buildings, but it's also designing the space so the space can match what we want to do in it. And you'll hear 4 clusters presentation today, and they will give you a sense of what we're looking for. But private sector also means the companies that we want to invite to be part of that space with us. If you're doing research on aviation, wouldn't it be great to have the greatest aviation company have an R&D team there? If you're working on next generation plasmas, wouldn't it be great to have some of the great companies of South Silicon Valley also do some research on plasmas there? And that's kind of what we hope to trigger today with our conversations. So an example of a cluster I want to show you, which is not going to be spoken today because we had to make a few choices. We only show 4, is Cubes. Cubes is an example of a research program led by our colleague Adam Arkin. And Cubes is really going to define the way life is built on Mars. So very ambitious things. So cluster looks like faculty that work together with NASA folks. And that's really the spirit of the meeting today, is that this meeting is part of a much longer series of meetings, summits, workshops that we've been conducting for now several years, and that we want to continue to accelerate the embedding and the construction of teams that can co-work on things together, funded by industry. So these slides, these things that you see are examples of companies that could also co-fund the work by Adam's work. And that's one thing we have done a lot of work at the university. One of the things we're good at, and especially in the College of Engineering, but even beyond, is the construction of industry consortia to fund research. And that's something that could really be of interest to both communities, the NASA community and the Berkeley community, because a lot of the work we do is high TRL level. A lot of the work we do has direct implications and migration path to the private sector. And so principles of industry consortia is that they can really help academics, and by that I mean really joint teams of NASA folks and Berkeley folks, or NASA folks and UC folks, to together work on some specific research topics. So now, before we get there, I think things start with people. And one of the great assets we have here is students. And so one of the things we've been working on now for many years, and I think one person really should be commended for this, is Professor Panos Papadopoulos, who really launched that first program, is creation of pipelines of interns. And the idea is that by co-funding things, essentially we can create a process by which we can match students with NASA researchers in a way that they can access prime talent. And we're doing this with the aerospace engineering cohort. We're doing it with the Citrus Workforce Innovation Program. And as we continue, we'll hope to develop a lot more of these programs. So it starts with students, but it also continues with us, the faculty, us, the research staff. And so things that we've been doing now for the last year and a half is the organization of several summits. The Aviation Summit was the first summit we created. There's been 2 innovation summits. Gauthier Vasseur, the director of the Fisher Center, is also in the room. He's organized 1 summit on AI. And so I think as we're starting to build this joint work, first we have to define an academic home, an academic scope. And that's when there is a lot of matching here, finding the right faculty to work with the right research staff at NASA so that together we can really get the best of both. And so part of what we're doing today is to later show you a few of these clusters that are automatic, that have started to spontaneously emerge, but also hearing the perspective from our leadership. We have the director of NASA Ames, Eugene Tu, and our vice chancellor for research, Kathy Yelick, and they will also give us a top-down perspective on how we intend to build this. So I want to leave you with one moonshot. And it's really something that we've been toying on with multiple for multiple years now, but which will become a reality, which is Airlink. So this is the decade of electric, automated, vertical aviation. And there's no better place than the Bay Area to experiment to see how this could be built. There's obviously a runway and a lot of different infrastructure at NASA Ames. We have a vertiport on this campus. So one of our aspirations, which will probably take another decade to build, is that we will also be the first university in the world to have air connectivity between our different campuses, which means once we operate at NASA Ames, we really hope that we will also be able to define an air corridor and maybe even pioneer the way low altitude helicopter traffic is operated around the Bay Area, not just from a research perspective, but there's maybe also a commercial angle. There's maybe a lot of other angles to that. And that's something which really is a dream place for students to be, because there's no better place to be where technology is invented and where technology is field operationally tested. Okay, so please join me in welcoming NASA Ames Director Eugene Tu.
All right, good morning. Still morning, right? Yeah. Good morning, everyone. It's really a pleasure and honor to be here, especially challenging to follow Darek and Alex, since they've already given you the full story almost. But I think that's a good sign, because what it really means is our stories are so well aligned. And what we're looking to do from the NASA perspective is very much similar, or if not the same, as what the university is looking to do. So this is what I hope you'll get out of this message. For me, it's really maybe full circle. 4 decades ago, roughly, I started my career journey here at Berkeley as an undergrad, and I did my first internship at NASA Ames just about 40 years ago. And so to be in a position now to help set the direction for the future and to help grow the collaborations that have been longstanding with the entire academic community in the Bay Area, and we know there's a richness of academic resources here in the Bay Area. To connect that back and grow that with NASA is just something I'm thrilled to do and personally vested in. So I'm going to start out and give you an overview of NASA and an overview of NASA Ames. I'm going to try to do that relatively quickly. Talk about a few areas where we are focused right now at Ames. And then also talk about some collaborations that have already begun or have been initiated through this. As I mentioned, we've been collaborating throughout our history, but we're at a point in time where we really can dramatically grow and advance this collaboration, I think, for the betterment of everyone. And so this is what I'm looking forward to. So what I generally start out with is a quick primer, which I will spend very little time on here, on what NASA does. When you go out and talk in the public, a lot of times people focus in on a few things: the Apollo missions, the shuttle, the International Space Station, maybe our rovers on Mars, and then they have to stop and think a little bit. So this is really the 5 mission directorates or areas of NASA. So NASA is fairly broad. And maybe the key message I want to leave you all with here is, as a research center within NASA, we work in every one of these areas, almost proportionally or equally. So that's not common. I'll tell you a little bit more about the NASA centers, but not all the centers work equally in all these domains. So from aeronautics research, the first A in NASA, to space operations and deep space exploration, to science, and ultimately the technology that is needed for NASA's mission, but is also developed for NASA's mission that benefit the public overall. Many people don't know that the Space Act that was established, that established NASA back in the late 50s, actually had language in it to talk about one of NASA's missions is to disseminate its knowledge, its discoveries, its technologies as rapidly as possible for public benefit. And so these are the 5 areas. And as I mentioned, Ames participates in, supports every one of these areas. So if you go to the NASA centers, there are 10 NASA centers across the country, including one FFRDC, which is JPL. All the other 9 NASA centers are government centers. And so point out a few things here. Some of these NASA centers are very much focused in 1 or 2 of those areas that I showed on the previous charts. The human spaceflight centers, typically you think of Kennedy Space Center, Johnson Space Center, Marshall Space Flight Center, and Stennis Space Center. Those are all primarily human spaceflight centers. Although they do support other missions, most of their work is in the human spaceflight area. The Goddard Space Flight Center and JPL are primarily science centers. Most of their funding, most of their work comes from the science part of NASA. And then you have the research centers, Glenn Research Center, Ames, Armstrong Flight Research Center. These are and Langley Research Center. These are the centers that basically conduct research across the entire domain of NASA and support multiple mission directorates in multiple areas. California is also the only state with more than one. We have 3 NASA centers in California. But I also highlight our presence in Silicon Valley, which was so well pointed out by Darek. It is both a opportunity and a challenge for us. The opportunity, I think, should be obvious. One of the most innovative entrepreneurial parts of the world. And all our neighbors, as Darek pointed out in his charts, all our partnerships, the richness of academic institutions from Berkeley to Stanford to UC Santa Cruz over the hill to Davis, to the State University, the Cal State University, San Jose State, East Bay, Cal State East Bay, and then the community colleges, also a richness of academic capabilities that's, I believe, unique in the nation and in the country. So these are areas, so being in Silicon Valley is clearly an opportunity. Of course, the challenges I think we all know about too. It is arguably one of the most expensive places to be for a federal lab and for NASA. And so we do have those challenges as well. And so those are the areas that we have to work on together. And often the partnerships that we're talking about here can help solve some of those challenges and problems. So a little bit of history. We're not quite as old as UC Berkeley. We just celebrated our 85th anniversary in December of last year. But we are the second oldest NASA facility, laboratory. The first one being NASA Langley. We were founded in 1939, so actually 20 years before NASA was formed. If you recall, I mentioned NASA being formed in the late 50s. So we were part of the original NACA, and so that's the National Advisory Committee on Aeronautics. And then we became, 4 NACA laboratories became part of NASA once NASA was formed. As you can see from the images there, Silicon Valley wasn't there at the time, of course, and in fact the region was very much not developed much at all. So, but our early days were in aviation and aeronautics. That's part of our route. We are much broader today, working in those domains that I mentioned, but we did start in aviation and aeronautics, and some of our key facilities still support the nation and the world in aviation and aeronautics. So this is what our center looks like today. You've seen multiple images of that through the earlier presentations. I like this view because it gives you kind of a bird's eye view of what I would consider to be 2 major parts of our center. So our center today occupies about 2,000 acres of federal property. The core part of the center, which has been there for the longest on the left-hand side, is what was there, started there in 1939 and was built out from there. And that is the core NASA Center, about 400 acres of property. We were part of, for a long time, Moffett Field Naval Air Station. And that Naval Air Station was closed in the mid-90s, and NASA took over the entire property. So the buildings that you start seeing the red roofs towards the right side of the image, and the parade ground, that is all what used to be Moffett Field Naval Air Station. And NASA has turned that into the NASA Research Park. And so with enhanced use leasing authority, as well as National Historic Preservation Act authority, we are able to get partners on site, lease out land, lease out buildings, lease out offices for partnerships. And we have many partnerships coming on site, including what I would consider the major anchor partnership with UC, led by UC Berkeley and the Berkeley Space Center. So what are some of the presents that we have on site right now? Many of you may know USGS Menlo Park. They are in the process of completely moving down to our facility here. In fact, that first red roof building towards the left of the parade ground there is going to be entirely occupied by USGS. They've also completed recently a new 50,000 roughly square foot wet lab building for their laboratories and experiments on site. So the USGS should be completely moved down by the end of this year, beginning of next year. We've had other partners on site. Carnegie Mellon occupies one of our buildings as well as a lot of small startup and incubator type companies. So just to size our center, we have about 3,000 employees, about 2/3 contracts and 1/3 government employees. We have about $1 billion in revenue each year for research and development and operations. Most of that is congressionally appropriated NASA funding, about 85% of it. About 15% of that $1 billion per year is what we call reimbursable funding, or funding we get from others. These are the 8 core areas of what we call our core competencies, or areas of research today, and I won't go through these in detail. Some of them already touch upon some of the domains that have already been discussed here. such as air traffic management. We, for decades, have been one of the leaders in research for air traffic management, with the FAA and the airline industry being the recipients of our capabilities and our products. But that has now advanced and morphed into what we call advanced air mobility. How can we better use the airspace for public benefit, whether that be in the urban environment or the more rural environments? So those are the key area. Entry systems. We are the entry systems materials lead for the agency. Most of the materials that protect spacecraft from entering the Earth's atmosphere or another planetary atmosphere were invented or tested or certified at our facilities. The SpaceX Dragon spacecraft, for example, their heat shield material is a variant of what we transfer to them technology-wise, and is continuing to be used on the industry side. And then, of course, for the NASA missions as well, and the probe missions that go to Mars and Venus and Jupiter and beyond. Advanced computing and IT, we host the agency's primary supercomputing facilities for the agency, and that has led to a great collaboration with Berkeley in hosting some of the Berkeley systems at our site, and we'll talk a little bit more about that. The intelligent adaptive systems area is where we focus our work on autonomy and AI, but maybe with also an increasing emphasis on human interaction with those systems. Ames has one of the largest cohorts of research psychologists in the agency, human factors experts. Some of you may know Crew Resources for Aviation. Cockpit Resources was developed at Ames. And so one of the key challenges with the increasing use of autonomy and AI is around how humans will interact and interface with those systems. We also know that's where many of the failures and mishap happen as well. Cost-effective space missions is another area that we are focused on. We don't run the large flagship missions. We certainly support them with science, with instruments, and with technology. But we do operate mid-size and smaller missions. And in fact, we are one of the pioneers, I would argue, in the last 20 years in the area of ultra-small or CubeSat type of space missions. Aerosciences continues to be a mainstay of our work, both experimental and in my own field. That I started in 40 years ago, computational aerosciences. And then the science areas, 3 key science areas: life science, earth science, and space science, with a particular emphasis on life sciences and astrobiology. I would argue one of the founders of astrobiology as a domain or field more than 2 decades ago, as well as looking at how we can advance life sciences to understand how we're going to extend human presence beyond low Earth orbit for long durations. Of course, with the people, we need to have major facilities to operate and to do our experimentation in. So, as already mentioned, we have the largest wind tunnel in the world. We have the only ArcJet complex. It's a 60 megawatt facility to test thermal protection systems materials. We have human-in-the-loop simulators. We have the largest motion-based simulator in the world called the Vertical Motion Simulator, as well as a 360-degree air traffic control tower simulator. Because we know, as I mentioned earlier, you've got to put humans in the loop. They're part of the system. Arguably the least predictable part of the system, but they're part of the system. And we need to understand how they're going to operate with increasingly autonomous systems in the future. Our supercomputing capabilities go beyond the traditional, I hate to call it traditional supercomputers, but also into quantum, neuromorphic, and more advanced computing concepts, because we need to understand how those systems will actually advance the engineering and science work that we do. And then, of course, we have a whole host of laboratories, science laboratories, as well as spacecraft development laboratories on our field. So now I'm going to touch upon, pretty briefly, some key areas that we're focused in. I'll go back to aeronautics. The truss brace wing is an example of a sustainable flight subsonic aircraft that has been tested extensively in our tunnels and our facilities. The low boom flight demonstrator, we're hoping to see first flight soon. And we're also NASA's also working with industry. You may have seen news reports of Boom flying their first vehicle, supersonic. We hope to see supersonic flight, commercial flight in the future. But one of the key questions there to enable that is, how do you fly supersonic over land without the typical sonic boom that would disrupt people on the ground? So the Concorde, one argument has been made that the Concorde was never economically successful because it was not able to fly supersonic over land. So that is one of the key advances in commercial supersonic flight that's needed. We also do a host of experimentation as well as computational modeling to support various areas of aerosciences and aeronautics. But I also want to switch to our area of advanced air mobility. This is revolutionizing the use of our airspace for the future. And one of the key areas that we've been focused on for actually quite a few years now is trying to advance air mobility for wildfire research. And we all know the damages that can be caused by wildfires and the fact that we have limited ability to attack them from the air and respond to them from the air. And so that's one of the areas that we're focused on. But ultimately, how do we scale our air traffic management system so it can handle 1 to 2 orders of magnitude more aircraft in the air at a given time? Today, our air traffic management system handles roughly 40,000 aircraft per day, but at any given time, about 5,000 peak number of aircraft in the air. The FAA estimates that's going to go up by 10 times, if not 100 times over the next decades or so, especially as you introduce regular use of unpiloted or drone type aircraft. Our current system does not scale, will not scale to that. And so how do we develop a system that will accommodate safely the introduction of those type of aircraft into the same airspace? When you talk about space, some of the key missions we're focused on, I already mentioned the small spacecraft missions. We have a mission right now called Starling that is 4 CubeSats working in conjunction with each other in space. Its primary mission was already successful, and now it's looking at how to maneuver with other assets and detect in a way that can address orbital or space traffic management, if you will, and some of the challenges we're going to face there. Heliophysics missions. Helioswarm is a mission that NASA Ames was just awarded and is now in phase B. And we're looking to launch 9 spacecraft that will work together. Think of these, I like to think of these as buoys in space, like you would put in the ocean, to really understand the solar environment. And so that's one of the key missions that we're working on right now and are excited about. We, of course, support the human spaceflight missions to a large extent. The heat shield material, the heat shield testing is all done at our facility. A lot of the computational modeling and wind tunnel testing is also done. And we've leveraged these systems to actually deploy secondary payloads or small spacecraft missions. BioSentinel was a mission that was launched with Artemis 1. And it is the mission that has at least intentionally tried to extend life the furthest away from Earth, and in an experiment to see what the response would be to high radiation environments. These are the type of missions and activities that NASA Ames is involved in support of our nation's efforts. And then I mentioned space biology. We have flown the largest number of experiments on the International Space Station, over close to 100 missions now in various areas of space biology. It's an incredible laboratory. We are also looking to how to do these type of experiments beyond the life of the International Space Station, which could be towards the end of this decade, but also further and deeper into space, especially into cislunar space. And then the missions to Mars and beyond. There are 2 missions that are being, one is actually in development and will fly soon, and the other is still in concept, and that's Mars Sample Return and Dragonfly. So Mars Sample Return is being reformulated as we speak, but we have to be able to do a first-of-a-kind round-trip mission to another planet if we actually believe we're going to settle people on another planet someday in the future. And so this is a type of mission that's very complicated. It's very complicated. And I would argue the most complicated part of it is not only getting to Mars and retrieving the samples, but launching from Mars. If you think about the infrastructure it takes to launch from Earth, we're not going to be able to create all of that, but we're going to need some of that to actually launch from Mars. And that's why it's so complicated to actually land on Mars and launch and return to Earth. In fact, the Earth entry part of that return is one of the most challenging parts as well, which is one of the reasons why Ames is so heavily involved in a Mars Sample Return mission. Dragonfly is a nuclear-powered octocopter, which is going to Titan. And Ames, again, is responsible for the entry part of that mission. It will release its octocopter as it's entering the Titan atmosphere and look for a suitable landing spot. And it's an incredible mission. We recently tested a half-scale model of that spacecraft for handling, to determine handling qualities in our large tunnel facility. And then underlying a lot of what we're doing these days is autonomy and AI. And so we've already had some experience working on the International Space Station with robotic assets and autonomous support assets. We're looking at space construction or construction on the another surface of a planet or the moon. So these are areas that continue to be advances that not only critical to NASA's mission, but also help here on Earth. So these charts, I probably won't go into detail since they were already covered in many ways, but you see here another view of the airfield and the property there and the Berkeley Space Center campus. So we are looking to advance. The vision here is how do we create a multi-user R&D campus right in the heart of Silicon Valley that involves government laboratories, research laboratories, academia, and industry. And so we've got many partners that we are looking to bring in, but several major anchor tenants, if you will, to help enable that. And so the collaboration here is key to our vision of the future of Ames as a future and as it exists as a research center for NASA. So let me just quickly finish up with some collaboration opportunities that have already started or ongoing. The Aviation Summit was already talked about, which was from April of last year, an incredible opportunity to bring it together many in the community who are very interested in the same type of areas and fields we've been talking about. We established a reimbursable Space Act agreement with UC Berkeley to host high-end computing assets on site, and those assets are in place. I don't know if they're actually up and running yet, but we're getting close. And we have a modular supercomputing facility, which is a 1 acre pad with 30 megawatts of power and cooling that has ability to host more systems in the future, not just for NASA needs, but for our partner needs. The students are, for me, a key part of it. And I know Alex talked about sort of longer term impact. I see that as a near term impact as well. And so we're getting started on that right away. With the start of the aerospace engineering program under the mechanical engineering department 3 years ago now, we have hosted and were able to bring a third of the first class of those students to be summer interns with us last year. And we're looking to do that with the second class and those who want to come back from the first class this next year. This can only grow and this can only benefit, I think, everyone. Especially the students, but also our organizations. So it's an incredible opportunity. These are just some pictures of some of the projects that they worked on at NASA Ames over the summer. And I would love to expand this beyond aerospace engineering. I'd love to expand this to the other domains, whether they be science domains, other engineering domains, social sciences, and business. The exciting thing about space exploration in the future is it's going to really involve everyone. And it's also the opportunities. What I love to tell students today is the opportunities are tremendous. It's an amazing time to be interested in space exploration and aerospace in general. And so the key is we need to inspire these students, the next generation, and bring these folks in. And we hope to leverage that to the best we can. So I just saw I had a 5-minute mark, which probably means I'm going to leave too much time for questions because I'm actually done. But I do want to highlight one thing. I love to finish with this chart. So I did go to Berkeley for my undergrad. We didn't have aerospace engineering at that time. So I went to Stanford for my graduate work. And we all know the collaboration and competition that happens between these two universities, world-leading universities. So when I became center director, two close friends of mine, Steve Smith, who is an astronaut from Stanford, Rex Walheim, who is an astronaut from here, UC Berkeley, gave me this image here of them both on the space shuttle when they both flew together. And it says to Eugene, best wishes from both sides of the bay. We can coexist peacefully in space. Thank you very much.
Today, what we're really concentrated on is identifying the programs and all the synergies and all the academic programs, because it's a field of dreams. If you build it, they will come, right? So we're pleased that we actually have identified some companies have a very, very strong interest. and aligning on the site. So it's exciting to talk about the academic research today, but it's also with the forethought that those buildings that you saw on that image could be up as starting as soon as about 2.5 to 3 years from now. So that's when the site is. I saw a hand up in the audience, or we can go to Sid.
So yes, we have a couple questions coming in. Let me just go with the first one. Are there ways that the public can help with your efforts?
I had the pleasure of speaking at an alumni club on Saturday. It's the Rossmore Alumni Club. It's a retirement community in Walnut Creek, and 60 Golden Bear alums. They all dressed. It was super cute. They all dressed up in blue and gold, and it was just an incredible opportunity. And they asked that same question. They said, "How can we help?" And I said, "Just tell people about it. Tell people about the opportunity that exists. Spread the message. We're in a time when the news cycle is just can overwhelm us, right? Every single day and minute by minute, the news changes. And so when you lose the energy of powerful, beautiful, wonderful things that we can create that is being subsumed by a negative press event, that's hard for us. It's hard for us to push the message forward and drive the mission forward when we're lost in this communication era. So educating, getting on our website, spacecenter.berkeley.edu, signing up for the newsletter. Our first one will be produced in next month, and just keep the knowledge going. Share us on social media. Talk about the really exciting things that we're already doing today, such as the aerospace engineering degree and a couple of the workshops that we're doing. Just help spread the message, mostly.
I think the other thing that can help from our perspective is, and I didn't mention this in my briefing here, but one of the things we're also very focused on is what I'm calling reaching out to the younger generation, right? The folks who are not yet in college or thinking about college. So we established, for example, a new relationship with the Chabot Space and Science Center, which is pretty close to here. They had hosted for a long time high school interns. They started middle school, but they hosted high school interns. And we leveraged with them to say, hey, can we bring some of those high school interns interested in coming down and spending some time at NASA? And so I think the earlier you get involved in terms of someone's life, and the earlier you try to inspire, that also, because the amount of public response to that, right? The city of Mountain View now is interested in, hey, is there a possibility of an academy or a high school close by or on our property? Because that's where the public really gets engaged, is when you start to really reach out and impact the public, especially children. Because that's, we've had people who said, hey, is there a model here where a high school intern will be able to come to Ames, and then maybe they'll be able to attend a university like Berkeley and still intern, and maybe they'll want to work for NASA or one of the other companies out there. And they can see that pipeline now, and that's where the public really gets interested, I think.
A question from online. What is going to be put in place to facilitate the communications from any researcher interested in collaborating with Berkeley Space Center?
So I think this question can be answered in two ways. I mean, so on the campus and even in the close orbits to the campus, LBNL and related circles, I think that the type of work we're doing now with outreach is really the inlet. As we're building this program, there is a steering committee. I think many of the members are here today who are helping defining all these inlets. So from the campus perspective, and I'd love to hear also from the NASA perspective, because NASA is a big organization, is really creating pipelines for faculty to understand how institutionally we can connect, if there is a map or a matching needed because of topical alignment interest, and then possibly at some point some form of institutional framework to support it. So we're building these processes as we speak. The websites on the EDU domain will serve for that. And then on the Berkeley side, the associate provost is the one of the focal nodes and hub, and essentially on the NASA side, my counterpart Sid is the equivalent. And I'm curious if maybe from the NASA perspective you want to give us similar answers, because I'm sure other centers beyond NASA Ames are also interested to work with Berkeley.
Yeah, to me, it's we need a key, and we have a key in Sid. By the way, Sid is my lead for university collaborations. We need a key focal point because there's almost too much that could be done, in the sense that too many ideas out there, and we need to kind of narrow that down and look at how to best move forward. I like to tell our folks there isn't any domain that we can think of that a major university like Berkeley doesn't have covered in some way or another, right? It's not the case for us. For us, we're very focused, if you will, as a NASA center on our mission and the type of work and domains we're involved in. A university is, by almost definition, very broad. And so there's a lot of expertise our folks could potentially tap into in the university that we wouldn't have on site or readily available. And so having that type of connection. The other key thing is, let's get down to the bottom line here, funding, right? Everybody cares about and needs funding in order to get some work done. And so what we are doing at NASA Ames is, with limited ability, with our IRAD funding, we will look for proposals that are actually joint with universities and academia to try to facilitate and inspire that. And so that's another key thing that we've put in place on our side.
Thanks all for this presentation. I guess I'm curious, because there is a lot of cross-disciplinary work that it sounds can be done across campus. How are you bringing that together, and how is NASA going to make the connections with the different campus groups and disciplines here?
I can start on the campus level. So the provost appointed a faculty steering committee to help with that. There's 18 colleges on campus, so rightfully so. It's a lot of organization, 1,500 faculty. So these type of events, again, are things we're going to try to do more frequently, that we will also try to do at a local level. And recognizing that, yes, I mean, if you work on space missions or the future of air travel, it's, you have to have engineering, you have to have policy, you have to have a lot of different subfields. So I think part of the future of that steering committee in the years to come will also have to transition from planning to operations. And that's very important to realize, because the last 5 years, when we've started to assemble the team, we're really mainly focused on planning. What are we building? What are we going to do? How is it going to work? What is governance going to be? But now, as we're getting closer to breaking the ground, and as Eugene rightfully so pointed, we have now collaborations happening. We're progressively transitioning from planning to operations. I mean, planning is going to still continue because it's a very big project, and we have to define our operations. So I think part of the job of the steering committee over the next 12 to 18 to 24 months to come is really to start defining this. And then they could take a lot of the different forms. One of the suggestions that we're starting this fall is actually a seminar series. So, for example, within NASA, Code A, Aviation, has already made a lot of head starts with working with Berkeley. So we're starting seminar series that will rotate between NASA and Berkeley, so that we have mutual awareness and can create such inlets, and hopefully that can be replicated in a lot of different units. And I'm curious, on the multidisciplinary front, if maybe there's also something to be said about working across branches of NASA Ames.
Yeah, so we have several ways we do that. As I already mentioned, I specifically asked Sid to lead to be the lead of our university collaborations. But more broadly, we also have that same challenge in that we probably don't have as many different disciplines, but we do have different disciplines. And a lot of times our missions will require collaboration between our science areas, our technology areas, our engineering areas. And so we also have some key positions. We have a chief scientist and we have a chief technologist for our center. We also have a research council, which is made up of the organizational directors of each of those major technical organizational areas. So we will tap into those existing structures that we have to make sure that our cross-discipline type of activities are also synced with the capabilities of our partners. In this case, it would be the Berkeley Space Center.
And let me give you an example about where we're trying to bring private industry engaged in that effort. So we held a seminar workshop between NASA and UC Berkeley over advanced aviation and all of the disciplines that are coming out and the new technologies that will be needed in the future. So the next sequence of that advanced aviation workshop will bring in the legacy, multinational airline companies, the startups that are working in eVTOL space, and all of the supply chain around that, right? Because in order for us to really understand what research needs to be done, we have to look at how does private industry commercialize that research? What are they most interested in? What do they think the largest opportunity set is? So when we think about all of those disciplines, Eugene's right. We got to narrow our focus to those clusters that make the most sense, where the largest opportunities are. And the 4 that I can think of that are right off the bat are, of course, advanced aviation, life in extreme environments. So how do we, do those human manned missions to Mars and keep people alive while they're there? Life sciences, so space health is another emphasis. And then just focus on space technologies in general, like small aircraft, small craft satellites and CubeSats and things like that. So this seems to be where the nexus is in Silicon Valley, and where a lot of those disciplines can advance. But it's not meant to be the exclusion of other disciplines that are also equally important, like high performance computing and quantum computing and things like that. So what we're trying to do is drive the communication cycle so that we can keep the message clear and make sure that we can engage private industry in the right way.
We'll take one more question from Sid, which he has online, and then we'll transition to our panel with the Vice Chancellor for Research. There will be at least 1 or 2 other Q&A sessions. So if you do have questions, don't worry, we will have other opportunities throughout the event. You had one more question online, Sid?
Yeah, so I'm going to bundle a couple questions together. There's a question for NASA. Ames has long been an innovator and leader in artificial intelligence. There's concern there's so much competition out there for that leadership realm. So how do you see this relationship, this collaboration, helping Ames in artificial intelligence?
So NASA missions have inherently needed more and more autonomy since the beginning, right? Because our missions tend to go far, and they tend to go to the point where far enough that you can't even teleoperate them, right? And so we're actually going to benefit from the increasing interest, technology development outside of NASA in the areas of AI and autonomy. We don't need to be the leaders per se. We need to be able to adapt and bring in that technology and modify that technology as needed for our missions. And so we don't see it as a threat that others are interested in this area. We see it as a benefit. You could argue that back in the day, the government and in NASA in some ways was leading in the areas of high performance computing and communications. The high performance communication and networking part, NASA actually stopped working on back in the mid 90s because it realized industry was going to take care of that. We could just leverage the advances that the marketplace would drive. And so I guess I would modify that to say that what we're really looking forward to is a partnership that will bring AI capabilities more and more into the type of missions to help enable us to do better missions and more exciting missions with greater science return. And at the same time, we will develop those in those areas that are needed uniquely for our needs.
Thank you. I think that's actually a perfect segue into our next sequence, because now we're touching on research. So first, let me thank Darek again for being here today. And then we will invite our Vice Chancellor for Research, Kathy Yelick, to this. Thank you so much, Kathy, for joining us. So maybe since we were just transitioning to research, before we even dive into the questions, I was wondering, from your vantage point at the Vice Chancellor for Research's office, if you wanted to give us maybe a very short perspective on how you see the general project impact research on campus with NASA, and then we will have pretty symmetrical questions onto how that works in both units.
Well, thanks very much, Alex. Thanks for inviting me to speak on this panel. And I think this is really one of the most exciting things happening across campus, and something that I think many faculty across many different disciplines will be able to take advantage of over the next several years as it is built and then expands, I think, the type of work that's going on. So if you haven't heard our Chancellor say, fundamental research is the seat of Berkeley's preeminence, you haven't been paying attention. But anyway, so fundamental research is, kind of what is the foundation of what Berkeley is built on. But I think that Berkeley's superpower in some sense is the ability to take fundamental research and then turn it into translational impacts outside of the academy. And so, we do that already in commercialization of biotech, and we're looking at commercialization of climate tech, and we have it in many other areas in policy. So not just in commercial entities, but I think that the Berkeley Space Center is going to allow that kind of both support fundamental research because of the kinds of facilities they have already at NASA Ames and the kinds of things that can be built there, but also then translation and delivering those ideas out into the marketplace. So I think maybe that didn't answer the question about kind of research, but maybe we'll get into that.
No, it totally did. And both of you touched based on this earlier. But I was wondering if from both your perspectives, you could tell us a little bit more what you think are capabilities uniquely positioned at NASA that Berkeley could use and vice versa? Because like you mentioned, we have very complementary capabilities and so does the private sector. The example of communication and maybe some fields of AI or robotics and automation are very compelling. But if you had to pick maybe 2 or 3 examples of things where Berkeley could make unique contributions by joining NASA in your facilities, working on your test beds, which are quite amazing, and you showed some of them, and vice versa, things we do on campus, and picking no particular order. I'll let whoever wants to speak first.
Well, no, I think that there's huge opportunities there with collaboration across facilities. We're looking to do that not just between NASA and Berkeley, but also with our other partners like USGS, as I mentioned, just built the state-of-the-art laboratory facility on site, and others are looking to do similar types of things. So if I had to pick a few, I think one of the areas that we're really looking to do, given where we're situated, the fact that we have a fully operational federal airfield and we're an urban environment, is an advanced air mobility test bed to really have an ability to fly, test, analyze in that kind of environment where we have, and we're all working with the FAA to establish corridors where we can do flight of drones. One of the biggest challenges is beyond visual line of sight flight. And so we've established a corridor called the Hollister Corridor, which Berkeley is familiar with and partnering with us on. We are also located right at the southern end of the bay. So if you just go north, you're flying over water. And so and then can reach almost every other part of the bay right from there. And so it's an incredible test bed opportunity, I think, in the area of advanced air mobility. We, of course, have a host of aviation aeronautics testing facilities, from the largest wind tunnel in the world to some of the fastest wind tunnels in the world. We also have entry systems testing facilities, high energy entry system material testing facilities. And then we also have the human in the loop simulators, where you really can bring together the areas of autonomy and AI with humans and test them in an environment where it's safe to test, it's safe to make mistakes, and it advances the technology. So those are kind of maybe the 3 areas I would highlight.
And one of the questions that was asked earlier, I think it's interesting because through these applications, we're looking at fluid mechanics, we're looking at operations, we're looking at human in the loop, therefore all the possible social sciences aspect to that. So I think it really illustrates all the multidisciplinary aspects that such work could generate. And I was wondering if we could maybe do the same exercise on the campus side. There's certainly unique things we have here in a variety of the ORUs and beyond that would be of interest to NASA and would really enable to engage a lot of the people here with interest in research.
Right. So, let me start with, I think, first of all, the technology and for, building air flight vehicles and things like that, and the material science and the chemistry for sustainable aviation fuels and a lot of other areas like that, kind of concrete, experimental science in those areas. I think the other broad area that is really important is the optimization and management. And as we look at putting more and more things into the air or into space, the question of how do we manage the traffic and how to, especially then, and the automation of those, I think becomes especially important. And then I think this other area of kind of the life and biology, life sciences and biological sciences is another one that I think is maybe not the first thing on people's mind when they hear about this Berkeley Space Center, but of course is both important in terms of understanding fundamental science questions about what kind of life is out in space, but then the very practical questions and immediate questions for human space flight. How do we keep humans safe and things like that? So I think those are, and if I can maybe just add one other one, which is, I think that computing and data, which is cross-cutting, not just in engineering or in CDSS on campus, but really across the campus with people really looking at those techniques in many different science disciplines and how AI and other methods get used in, applied mathematics, but also then applied to other areas in biology and chemistry and physics and so on.
Thank you. So I'm going to switch gears a tiny bit, mostly because of questions that Darek and I get all the time. And so now that I have both of you on the stage, I think it's a very nice way for me to pass them to you. But so they're more process related, but they're very important because I think the nature of what we're building here is both institutional, but it's also infrastructure based, it's people's based and process based. I think the first question goes to you, Eugene. One question I often get is about Space Act agreements and how they work. And so since we're being recorded and this video will serve later as a tutorial for people who want to join, I figured I would use that opportunity to maybe ask you that question first, if you could give us maybe 1 or 2 minutes on understanding how that works, because this is not something that necessarily all of our faculty are familiar with, how that can be used to build the center. And then I will have a follow-up to both of you.
Okay. All right. Should have brought my lawyers. No, I'm just kidding. I'm just kidding. So no, Space Act. So the way I'd like to describe it is NASA has an incredible authority. It's called the Space Act, which basically allows NASA to enter into agreements, either non-reimbursable, which is probably the majority of the agreements we enter into, or reimbursable agreements where somebody's actually going to pay or money gets transferred. And it can be the reimbursable kind are two kinds. There's reimbursable, which is funding that comes to NASA, and there's funded Space Act agreements where NASA sends money out. But let me start with just the general premise around Space Act. What my predecessor, so I'll put it on him in case it isn't entirely correct. What my predecessor used to like to say about Space Act agreements and why it's an incredible authority that is given to NASA, not all parts of the US government has it, is basically the Space Act allows NASA to enter into an agreement as long as it's not prohibited by law. Right? Most other federal agencies can only enter into agreements that are allowed by law. They're given specific authorities to enter into an agreement, and they can enter into that kind of agreement externally. NASA is given the authority to enter into any agreements as long as it's not prohibited by law. And what that means is that we have many, many Space Act agreements. I probably sign at least several Space Act agreements a week. And these agreements typically last 5 years. They can last longer, but they basically allow for a collaboration between NASA and an external entity, whether that be a university, whether it be another company. And in some cases, it's not called a Space Act, but it's with other parts of the federal government. But it basically enters into a collaboration agreement where NASA brings its capabilities or expertise to the table, and the other partner does the same. And for a common desired outcome, right? And so it really is a very, very powerful tool that allows us to collaborate. In most cases, a lot of times it starts out as a non-reimbursable agreement, so there's no funding exchange, but we bring sort of in-kind resources to the table and can do so legally and can do so under this type of agreement. But there are also ways where funding can be exchanged through a Space Act agreement. So.
Thank you. And so that's a pretty good lead into the next question, which we get asked all the time, which now goes really to both of you, is that I think one of the premises and one of the aspirations of the Berkeley Space Center is that together teams comprised of academics, so faculty, and NASA staff or researchers jointly can definitely create projects where by applying jointly and seeking funding jointly or resources jointly, in some ways create something that doesn't exist anywhere else. And we do have experiences on this campus with LBNL, completely different setting with a different agency, mostly the US Department of Energy. We look with envy or at least admiration to JPL and other places in your orbit. that maybe have achieved similar agreements with other universities, in that case, maybe Caltech. And so my question to really both of you is, as we think about the Berkeley Space Center that we're going to build over the years, not just the infrastructure, but the processes and the people, what are ways that are institutionally feasible, legally feasible, can really leverage both families' strength to create such opportunities? Given the limitations, I understand NASA is a federal agency, so federal agency has issues receiving maybe federal dollars, given that we're public universities from the state. And so the question really goes to both of you, because there's the experience on campus and then the experience of the agency as a whole, possibly with other universities.
Right. Well, I'll start. I think one of the ways is what we just talked about, which is a mutual agreement that we establish where university has its resources, we have our resources, but we know that by collaborating together and putting an agreement, we're going to be that much better in advancing our goals. So that's one approach. The other approach, which is also quite common, and certainly Ames as a NASA center engages in it, is to actually jointly propose, right? Form a team together. Many of our, in fact, I would argue almost all of our missions that we propose to even within NASA, to the NASA Science Directorate, for example, are missions involving other partners outside of our center and outside of the agency. And so forming teams, often the PI might come from a university, and the mission operations part of the proposal or project leadership would come from the center, or some other way, right? So we bring industry in too. So sometimes it's a joint proposal involving a university, PI involving NASA mission capabilities, and involving an industry development capability. So we can jointly propose to NASA missions. We can jointly propose to others as well outside of NASA, and so that's another way to forge that partnership to go after other funding that's available out there.
Thank you. And I'm curious, Kathy, from your prior experience at the Lawrence Berkeley National Lab, and of course now as a Vice Chancellor for Research, you must have seen also other cases in maybe other agencies that maybe can be replicated or at least are inspirational to what we could do here.
Well, yeah, and maybe I'll say a little bit about my experience. As for those who don't know, I spent about 10 years leading computing program and supercomputing center up at Lawrence Berkeley National Lab, and have throughout my career, since for almost 30 years now, have had a joint appointment at Berkeley Lab. And so when I think about the kinds of work that I do at the lab and the kinds of work that I do on campus, I think there's a good analogy here is, there's some projects where you want to really build something very large. You want to do big science. You want to do team science. We're seeing this even more in areas like computation, my area, where you've got big teams of people looking at training neural nets and things like that. It's not just an individual scientist sort of field anymore. And I see a lot of science moving in that direction. And the advantage of working with an organization like NASA Ames or with Lawrence Berkeley Lab is they have full-time permanent scientists, right? That is their job. All of us on campus as faculty, we have at least three things, right? You've got service, teaching, and research. And so you're always, you've got a lot of different things that you're doing during the day. And the other thing is that, of course, a lot of our research on campus is done with graduate students and postdocs. Phenomenal advantage of having this constant stream of new ideas and energy that comes from having graduate students and postdocs that turn over every few years. And I think that NASA probably hopes to benefit from some of that kind of energy by working with students. But a different thing that is harder to do is to have a long-term project that's going to, for example, build a piece of software that you want to have running for the next 20 or 30 years, right? Forever, sort of, you want to be able to sustain it. Doing that entirely with graduate students is very challenging. And it's not necessarily in the best interest of their career. And that comes up in other areas where you need engineering. So I'll point to Space Sciences Lab, right? Fundamental discoveries in space, I think very complementary to what we're going to see in this kind of partnership. But you have a lot of engineers there also, because you're building things. You're going to build, big missions and devices that are going to go up into space, and they need to work. So on the main campus, with the exception of SSL, we don't have a lot of those kinds of long-term engineers, and that allows you to solve really big problems that you can approach them as a faculty member, you can work on them, but are you actually going to follow it all the way through to implementation? I think it's much harder. So, joint funding opportunities, the easiest thing, believe me, my office, we see a lot of these. We're subcontractors, we're prime, then we subcontract with them. Those are quite easy. But then I think these other kinds of agreements we will be looking at, especially then when we move outside of the kind of basic research and try to understand how do we deliver things that might have a partnership with a company and things like that as well.
And so this is a very nice segue into the last question I want to ask, assuming there's might be a few more online, and then opening it again to the audience here. But one of the most rewarding part of this job is both when I go on campus and when I visit NASA, I get the same question on both ends. A lot of NASA folks ask me, how can I teach at Berkeley? How can I do research at Berkeley? How can I get involved? And of course, the same is true. There's no teaching per se at NASA, but a lot of Berkeley faculty, research students ask me, how do I get involved at NASA? So maybe I know that sometimes the devil is in the details, but I think there is general aspiration that one day lots of people at NASA might be able to teach as part of our graduate programs or undergraduate programs, that vice versa, people might be embedded, that maybe one day we'll be hiring permanently located people at Ames to just be embedded there. So I was wondering if from your experience, both with LBNL and with NASA, you could describe a few examples of things that are already possible and some which we're working on. Like, I understand teaching has some intricacies. Same with research appointments in the federal government, but maybe a few examples to help the audience understand and mostly answer questions that I get all the time. How do I teach at Berkeley? How do I work at NASA?
Start with that one. So, of course, there are a number of different models we currently use with the lab with Lawrence Berkeley National Lab. That includes adjunct appointments for people that are lab scientists that come to campus and then are teaching and supervising or co-supervising PhD students, things like that. We have some of them have PI status on campus as well. If they have an adjunct appointment, they are PIs, but sometimes there's other kinds of appointments that people are still allowed to have PI status so that they can directly write proposals from the campus. I think that we have had a smaller number of actual joint appointments, that is 50-50 appointments. So those are much more complicated to figure out how we would, get them implemented, but I think is something we should certainly explore with NASA Ames. And I think that, there's a lot of other models of how we can work together on research projects. I think the other thing I'll just want to put in a plug for is our undergraduates. So, 33,000 undergraduates who are spectacularly talented across a large, set of disciplines, and that I think many of them will have interest in that. I'm so excited about the internship program that's already been set up, but I think we could send you 200 of them, and I think they would still all be outstanding, and probably even more that would also fit in with the mission. So if we can figure out a way of scaling that up, I mean, graduate students also, I often say people don't come to our department to work with the faculty; they come to work with our graduate students because they're so good. So I understand that that's a big piece of it as well. And we do have, in some cases, for example, outside people that are approved to be on a PhD committee and things like that. So there are ways of doing that kind of on an ad hoc basis.
And I would just, first of all, completely agree on the students. That is one of our primary, one of the primary benefits we see moving forward, and why we're so excited about even kickstarting that now. On the faculty side and researcher side, I'll start with, I have a vision that at some point in the future, we will be able to do joint appointments. It's not so easily done compared to SED. There are things we have to navigate because there are ethics rules and things like that have to be addressed, and authorities that have to be addressed, particularly for those who are federal employees. But we're looking at that. One of the things that we see happening for the entire agency is a closer partnership with externals. For the operational centers, it typically means with companies. And so there's already a legislative proposal that's out there. Every year, NASA gets a list of things it can forward as possible legislation that would benefit. And there's a legislative proposal out there to look at allowing more seamless movement of federal employees, NASA scientists and researchers in particular, with industry, with the private sector. I would love to see something similar to that proposed between NASA and the academic sector, and in this case, the university. And so those are the type of things where I do see the future of a possibility of trying to achieve joint appointments. Short of that, we do already support the adjunct position type of things. We have researchers who teach courses at various universities around the Bay Area and around the world, actually. And so there is a demand for that on our side. Many times, especially when I started at Ames, I know that many people were trying to decide in their career whether they wanted to work at a NASA research center or they wanted to go into university or academia, right? And so there is that similar interest among the people that we are both trying to bring into our institutions. And so why not look for an opportunity to give them the best of both worlds?
Oh, we have one question from the audience. Yes.
Hi, thank you very much. Einor Sawyer from UCSF, and we have the UC Space Health Program across researchers across the UC system, and we've been very happy to be involved in this. And I just want to ask if you could address your intention for having researchers from other UC campuses. We can speak to it from the space health side, but there might be other fields as well. Thank you.
So it says Berkeley Space Center, but I get asked that question all the time. And really, we view ourselves as a portal to all the UC. The Chancellor, even himself, uses the term platform. It's like the Berkeley Space Center is really a platform for a variety of activities. So the answer is absolutely yes. And that's particularly important in the case of UCSF because we do not have a medical school on this campus. But even beyond that, I think even with the Citrus organization, which spans the 4 Northern Californian campuses beyond UCSF, so Davis, Merced, Berkeley, and Santa Cruz, we do recognize the diversity of talent. For example, in AgTech, Davis and Merced are spectacular. So that provides some very specific part of robotics, which is very applicable to the space because of the unstructured environment and so on and so forth. So the answer is absolutely. And in fact, UC Santa Cruz has already worked very, very actively on running teaching activities at the Berkeley Space Center. So they might actually be the first to do that. And we would love if UCSF, maybe with your program, would also enable us to advance space medicine and space health, because that's definitely something which has a lot of importance in the Berkeley Space Center. And I wonder if you, maybe from your perspective, Eugene.
No, very, very similarly. I think I've always seen this, we have always seen this as two institutions, right? And the institutions are really the University of California system and NASA. And we're represented, we're one center in NASA, but we also are looking to be a portal to other centers at NASA. Because we don't do everything that NASA does, even though we touch every domain, as I mentioned in our area. We're not the ones you go to for aircraft propulsion, for example. That would be Glenn Research Center. We're typically not the center that's really focused on rocket propulsion. That would be Marshall Space Flight Center. So we are interested in helping to be that portal to the other parts of the agency, just as I know Berkeley and Berkeley Space Center are interested in being a portal to the rest of the UC system. So I think that's, and there is another possibility that Alex and I think Darek, you were there when we went to the public partnership conference that CU Denver was hosting. We met someone from I think it was Texas A&M, and Texas A&M has just signed an agreement with the Johnson Space Center to build on their exploration park, some facility there, and they're looking also to partnership there. But then, discussions occurred there that realized, well, even other university systems might be looking to partner with NASA, but not necessarily the NASA center they're closest geographically with because of the domain they're interested in. And so this could expand to things that even go beyond the UC system if there's interest there.
I don't know if you wanted to elaborate on this, but certainly from our perspective, the higher the critical mass of faculty, regardless of affiliation and hats, the better, because we're really trying to create an ecosystem of technical expertise. And so people come from a variety of backgrounds geographically and institutionally. So the answer is like from our perspective, absolutely yes. And
well, I was just going to say, Alex, in your current dual-hatted role, that also having this here in this building and with Citrus kind of helping to get things launched with the Berkeley Space Center already brings in 3 of the other campuses, not UCSF in that particular case. But I think it also just speaks to the fact that we do want to include all of the UCs in this.
In fact, the last speaker today would be Ricardo Sanfelice, who is from UC Santa Cruz, who will be represented by Mark Mueller, just because he's on travel. That's a perfect example. I think we have time for 1 or 2 more questions from the audience before we transition to the next segment.
Regarding the joint appointments, there are some examples in other parts of the country. I was at Oak Ridge for a long time as a federal employee, and part of our lab was actually funded by Oak Ridge Associated Universities. And I know at NASA Goddard, I think they have associated universities with Maryland, for example. I don't know of this around here in the Bay Area, so it could be established some sort of institute like that could be kind of that third person in the stool, essentially, for that.
I think it's a very good point, and looking to other universities here might be more helpful. The problem in some sense of using Lawrence Berkeley National Lab as a model is they are University of California employees also. And so it's sort of like they're already inside the tent, right? So we have to look for, yeah, that's a good point.
Hello. I have a question about the connection with the Berkeley Space Sciences Lab, because that's a very powerful institution in space exploration. They lead several missions funded by NASA. And I think it is a key player, and I would like to understand a little bit how that's going to be integrated with this plan.
I can start, but you should both give your perspective because you're extremely familiar from both angles. I mean, so they've been part of the conversation from the beginning. In fact, I think Steve Beckwith is one of the first people that Darek and I went to see when we started working on this project together many years ago when he was the director. But I'd love to hear from both perspectives because they are directly under the Vice Chancellor for Research as one of our biggest ORUs. And of course, they work very closely with you because they fly stuff with you. So I'd love to hear from both your perspectives.
Yeah, I thought Stuart actually might have been here a little while. Stuart Bale, who's the interim director right now at Space Sciences Lab. And so I see this as very complementary and something that will absolutely strengthen Space Sciences Lab as well as then strengthen the collaborations that we have with NASA Ames. And I look at it as sort of the same way. Those science missions at Space Sciences Lab, as I mentioned before, they have a lot of engineers and things that help to support those missions, help to build the systems and things like that. But they're really looking at fundamental science questions for many of those science missions. And I think that this question of sort of how space is getting commercialized, how are we going to interact with these other kinds of space organizations is one that will help, I think, Space Sciences Lab also navigate into the future. And I'm looking forward to working with, the executive committee we've been talking to about this, but also, in the middle of a search for a director to help us think about how do we, really strengthen the Space Sciences Lab itself with this in mind. So, Eugene.
Yeah, I mean, the Space Science Lab to me is almost a existence proof of the type of collaboration that we already have and can be grown. I mean, I believe the majority of their missions are NASA missions that they're supporting. They are part of the Helioswarm mission that I mentioned earlier. So I see this as a huge opportunity to both leverage that collaboration that's already been longstanding, but also see how that can be grown as part of this partnership.
Thank you. So we're nearing the end of this panel. So first, let me start by thanking both our Vice Chancellor, Kathy Yelick, and Eugene for their participation here today. What we're going to do now is we're going to transition in the last session of the event, in which we will have 4 clusters present in some ways the state of the art of their thinking. So clusters is something we briefly touched on. This is a very, I don't want to say top-down project because this comes with connotations, but it's true. I mean, something of that magnitude is not something that is bubbling from bottom up. And so there is some level of central planning, but it doesn't work without the involvement of the faculty and without the involvement of the people in the trenches like ourselves who do the work. And so part of the mission over the next years to come before we build the infrastructure is to create these affinity groups that will be working together on all the opportunities we mentioned, whether this leads to jointly funded work, whether this leads to joint appointments or teaching, etc. And so in the spirit of giving you a little bit of an overview or preview of what will be happening over the next couple of years on the ground, we have asked today to 4 of the leaders of these groups to come and give a short presentation on the joint work and joint thinking done together by the UC and Berkeley. So before we welcome them, I want to again thank both our Vice Chancellor and Director, and then we'll transition. Thank you. So the first of our 4 speakers, as we switch the slides, will be Mermaid Stockpool, who is the branch chief for thermal protection materials at NASA Ames. And so she will be giving a very short presentation to show the cluster work, and then we will transition to the next clusters.
So I will be filling in for Raj Venkatapati. Raj, working with Mark Asta, are going to be co-organizing the Materials for Extreme Environments upcoming workshop here in April at UC Berkeley. I'm the branch chief for the Thermal Protection Materials branch at NASA Ames, and I'm going to give you a little bit of an overview. So Ames, we've been a leader in thermal protection materials and entry systems for over 7 decades. And that really started, and we can go back to the blunt body concept and Harvey Allen in the 50s, and then with the development of ablator materials that led to us being able to return astronauts from the moon. Looking at the many missions that NASA has supported, if there is an entry segment to it, either human or robotic missions, Ames has been a key part of that. A lot of the thermal protection materials and the associated tools have been developed at Ames. So for example, looking as far back as the shuttle tile materials and the coatings, and more recently, you're probably familiar with the OSIRIS-REx mission that brought some samples back from Bennu. The TPS Pika for that mission was developed at Ames. And more recently, we're currently supporting Mars Sample Return Earth Entry System. We have a new highly reliable TPS that we are developing for that. And Eugene touched on the Dragonfly mission to Titan. Again, our TPS materials are baseline for that system, and we're also sizing. So the necessary tools are also a key part of what we're doing. So as we are looking at exploring the solar system, I know there's a lot of interest in water worlds, whether it's Enceladus or Europa, but perhaps the most important to us at the moment is Mars Sample Return. And as we look at bringing back environmentally or biological samples that are critical, things to keep in mind, it really is more than just the entry. You need to be thinking about the capsule design. For example, in this case, you're looking at high reliability, resilient materials because they do impact, and you want to make sure that your samples are pristine after entry and impact as well. So one of the things that has allowed us to remain a leader in this area is the ArcJet complex at NASA Ames. Eugene had touched on that previously. This is the best ground-based system we have to simulate entry. And it is a complex and expensive system to operate, so you want to make sure that you're getting value for each of those tests. So just on the bottom right, this gives you an example of a typical ArcJet test, a pre and post image for some of the materials. You'll see there's quite a lot of instrumentation. We want to make sure that we're getting good information. They're instrumented. We have in situ diagnostics. So this is one of the key capabilities that we're bringing. The other thing that's important, where there's a nice collaboration between Ames and Berkeley, is our computational materials groups. So more recently, I think they've been key to understanding things like anomalies, failure modes, as these materials are going through change, as they're exposed to temperature, an understanding of that. And perhaps we're now changing the architecture, and designing different microstructures for improvements moving forward. So just to touch on a couple of slides that Mark provided, again, just highlighting the complementary nature of work. So excellent experience at Berkeley in the areas of material discovery, materials characterization, and also he mentioned the new manufacturing 360, looking at the life cycle of a material all the way from development to end of life. And I think there are a couple of examples that we can touch on to highlight that synergy. The first one just on the top right, here we have an image taken. This is from the Advanced Light Source at Lawrence Berkeley. We actually use that facility quite a bit. We want to understand what's happening in our materials as they're going through exposure to temperature and load, for example. And then we have a suite of tools where we're taking those CT images and feeding them into. So already, I think a nice collaboration there. The other thing to point out, at the bottom right here, we have a nanostructure that's been exposed to a high dose radiation. And then this is just pointing to the long history of looking at radiation effects on materials here at Berkeley, particularly in semiconductors and in metals. So just again to highlight, this is the Resiliency in Extreme Environments Materials Workshop. We have a tentative date of April 10th, 2025. And the topics: materials for extreme temperature environments, materials resilient to radiation, and then making modeling and measurement capabilities for advancing materials discovery and development. And Mark Asta and Raj Venkatapati are the POCs. So I expect they are encouraging you to reach out to them, and we'll see where it goes. Thank you.
Thank you so much. So then it's my real pleasure to invite my colleague Rebecca Abergel, who is a professor in the Department of Nuclear Engineering and Chemistry here, to talk a little bit about biology.
Good afternoon, everyone. So I'm a faculty in the Nuclear Engineering Department, and I'm here to introduce you the second theme around which we want to foster collaborative efforts between NASA, Ames, and UC Berkeley and other UC campuses. And all of this stands at the intersection of biological systems and extreme conditions. So I'm going to give you a very brief, high-level overview of some of the research areas of interest in NASA. I'm from UC Berkeley, so I'll try to represent the best I can. But in general, some of the research focus is around understanding how biological systems, from microorganisms to human organ models, will respond to the very extreme stressors that may be encountered in space and in space flights and under those extreme conditions. There is also interest in trying to understand how one could develop countermeasures to enable life in space. And some of the topics of interest are listed here. The research areas focus on human health and performance in space, spaceflight payload development, bioengineering and synthetic biology, and environmental control systems to support life in space. It's important to highlight there are a lot of specialized and unique facilities and capabilities, both at NASA, but also on UC campuses, including LBL. And this is including radiation research labs, biological sample repositories, human performance labs, as well as some computational analysis tools that can be applied to those topics. So for the sake of being brief, I want to introduce you the next workshop that will take place after the materials workshop. So the date hasn't been finalized, but it will be towards the end of the spring semester or early in the fall of 2026. The theme is around biological systems and human-machine interactions in extreme conditions encountered in space. And some of the topics of interest are here, but this is not an exhaustive list, but mostly looking at effects of radiation, temperature, zero gravity, and other stressors. Also thinking about new methodologies for image reconstruction, computational biology, and anything around human-machine interactions. So we're hoping to get people not only from the engineering departments, but also other STEM departments, as well as the social sciences from UC Berkeley and other campuses, UCSF, UC Davis, Santa Cruz, and Berkeley Lab. And the point of contacts at Ames are Amy Gresser and Egle Chikanavichute, and I am the point of contact for UC Berkeley. So hopefully we'll get a lot of interest in this.
Okay, thank you so much. So next, we're really excited. We'll have Michael Lowry, who is a senior scientist for software reliability in the Ames Exploration Technology Directorate, and he will talk to us about robotics and autonomy, which he's leading.
Hey, I'm representing Intelligent Adaptive Systems, which is looking to have a workshop towards the fall, probably here in Citrus in early September. The dates to be determined. But before that, we're looking to spin up a working group that can help to determine some of the facilities that we might have at the Berkeley Space Center as the building progresses, and to complement facilities that we already have at NASA Ames, such as the Mars Yard, Future Flight Central, and a lot of facilities that can really help with respect to, for example, small spacecraft and robotics. So Intelligent Adaptive Systems spans all of NASA Ames. It's particularly concentrated in Rupak Biswas's Exploration Systems Directorate, but we also have our colleagues in Code A Aviation, and also the projects. It encompasses intelligent data systems, which includes distributed teaming and knowledge extraction, system diagnosis, prognostic physics models, integrated data systems, machine learning and data sciences for sciences discovery. For example, Nikun, who's sitting in the audience, has helped to develop machine learning to classify the expanding set of exoplanets that we have. Autonomous systems and robotics, planning and scheduling, machine learning for automation, which has really been growing recently, intelligent robotics, human autonomy teaming, which is particularly concentrated in Code TH, and that enables effective teaming between humans and robotics, which would be absolutely essential, for example, in a human Mars mission, and also anticipated in the lunar missions that are coming forward. And then to enable this to actually work, we need to have robust software, and we need to have good systems engineering, which is resilient. For example, Anupa Bajwa on the back there has headed up some of our efforts in resiliency. And we're focused both on space systems, such as constellations of small spacecraft, and also aviation. So the workshop is expected now to have topics that include robotics, particularly space-oriented robotics. We're actually having a workshop, as I speak, on off-worlds resource extraction that will enable in situ use, and also possibly eventually a space economy at NASA Ames and at our conference center. Autonomy, absolutely essential as you get further out into the solar system, exploring the system, Martian and lunar habitats, for example. AIML, for example, large language models that you can take with you to Mars and can help you to diagnose, manage the mission, determine if you need to actually respond with fault response. Think about taking mission control and then taking it with you on a spacecraft. And then, as I said, in order to make this all work, software and systems engineering in the context of extraterrestrial operations. The workshop skeleton is to have plenary sessions in the morning, then lunch. Breakout sessions would be 4 to 6 topics. We'll have a snack, then we'll report back from the breakouts and then close. Once again, targeting early September, but in the meantime, please contact Alex or myself with respect to being on a working group that will be exploring, among other things, enhancing the collaborations, and we have a lot of collaborations already in autonomy and robotics, and also to try to determine some of the facilities that we might ask for in the Berkeley Space Center. Thank you so much.
Thank you so much, Michael. And so this brings us to the last cluster on aviation and advanced aviation. Today it will be presented by Mark Mueller, who is a professor of mechanical engineering, on behalf of Ricardo Sanfelice, who is the director of Citrus Aviation at UC Santa Cruz. And Mark?
Thank you, Alex, and good afternoon, everyone. So I'm here on behalf of Ricardo, who can't join us today, to speak a little bit about the Advanced Aviation Thrust and the efforts we've done. And here I want to talk about two things. Early last year, or April of last year, we had a fantastic event down at NASA Ames, sort of a technical summit, which was co-organized by Citrus Aviation. So we had a lot of different researchers and then folks from NASA as well, discussing the Space Center as well as the sort of common research interests. So this was researchers primarily interested in urban air mobility, discussing the future of sustainable aviation in this context. There were a bunch of breakout sessions, brainstorming, lots of interesting discussions that came from this, looking at also especially industry partners and how we can exploit the potential of electrical vertical takeoff and landing systems. And we talked about sort of examples that we see here: eVTOL technologies, autonomy and design of these systems, specific applications, technologies that we need to develop to enable these, and airspace operation and integration. And then we are having another event similarly that will be somewhere in May of this year. I think the date is not quite finalized yet. This will again be held down at the Moffett Field facilities. Following up on what we did, what's new here and what we're really driving for here is this industry engagement, as Alex has also emphasized. So we're planning to bring in a lot of sort of industry partners and have them really participate in this event. So if you're interested in this, there are lots of things that we're interested in sort of pulling up on. So if you're interested in potentially being a speaker or panelist, watch out for the call that will come. There will be lots of opportunity for industry to sponsor and participate, and then also for students to participate. And if you are, you can see where I'm pointing, I apologize. If you're interested in more information, you can reach out to Ricardo on the UC side, or Leighton Kwan on the NASA side for more information. Thank you. Thank you.
Thank you so much, Mark. So this pretty much brings us to the end of our event. So first thing I want to say is that 4 is only a small number of all the different themes that we have been discussing and pursuing over the last many years. In fact, if you look in the Russell report, which I mentioned at the beginning, you will see there's a lot of other themes which are at various degrees of completion and crystallization. But the point is that if there are other people, either here in the audience or people who are watching us online, who think they have really an interest in a different topic where they could assemble a workshop to get started on how we can assemble the two teams together, please contact me on the Berkeley side and Sid, my counterpart, on the NASA side. So technically, we have a little bit more time for questions. So I'm going to just pause here for a few seconds if there's some general questions that are of interest with the people here. But we do have refreshments and some food out there. It's somewhat past lunchtime already. So we can also continue that process of questions in a less formal manner afterwards. I'm just going to take a mini pause in case there is a question of interest to the entire audience. And the norm in some other federal agency is 4 seconds. That means no. Getting there? So that's an official no. Good. Really, I want to thank everybody for their participation today. It's been a really great event. I want to thank Director Eugene Tu for coming from NASA, our Vice Chancellor for Research, Kathy Yelick, Sid, Sid's son, my counterpart, and partner in crime for many years at NASA Ames. Mermaid, Rebecca, Mike, and Mark for speaking on behalf of the cluster, on behalf of Ricardo, Darek, for the instrumental work in shaping the entire Berkeley Space Center from the very beginning, and for being with us today, as well as our team, Emily, and Amy, who are here today. For the NASA audience, I know a lot of you have actually driven from the other side of the bay. We've done it multiple directions at every possible time of the day and the night. We know that's difficult, so thank you. And the steering committee who was here at least for part of the time for this. And so with this, again, thank you.